This is lesson 3 of the topic Matter 1, and today we will be learning about properties of the elements. The key words for this lesson are element, metal, non-metal, solid, liquid, gas, shiny, reactive and unreactive. Now first of all, we have a knowledge check to complete, so make sure that you pause this video to give yourself enough time to do the questions before the answers appear. The rows on the periodic table are called periods. The amount of elements in period 1 is 2 elements. The symbol for potassium is actually capital K. Make sure that it is a capital, because when we use symbols for elements, the first letter is always a capital letter. For helium, the symbol then is He, and that first H, that needs to be capital H and then a lowercase e. The columns are called groups. The symbol for phosphorus is capital P. Make sure that it is a capital. The elements are placed in order of atomic number. And the person who designed the modern periodic table, it is Dmitri Mendeleev. So as long as you have Mendeleev, okay, because that is the main name that he is known by, but his first name is obviously Dmitri, make sure that you know that name. So Mendeleev is a very important name in terms of the periodic table and its history. Now, make sure that you mark your work in a different coloured pen. So make any corrections that you need to and add in answers that you don't have. So, the thing that we are hoping to do by the end of this lesson is to state some of the properties of the first 20 elements. And in order to do that, the first thing that we are going to do is look at a brief look at human history. So, the Earth is about 4.5 billion years old, okay, which is obviously an extremely long time. Now, modern humans, which the scientific name for those are Homo sapiens, they have been around for approximately the last 50,000 years, and in that time they have made many discoveries. Now, we had ancestors that existed millions of years before modern humans. Okay, so these were more like our impressions of a caveman, so very simple. Obviously, their language would not be the same as ours, their clothes would be very different. Okay, so we have ancestors dating back millions of years. The duration of human existence can be divided into 3 main ages. These are Stone Age, Bronze Age, and the Iron Age. Now, Stone Age is obviously the oldest, then Bronze Age, and then the Iron Age. In each of these ages, humans used materials to make tools to survive. Okay, so when we look at different ages, those ages are known because of the materials that past humans, so our ancestors, the materials that they used to use to make tools. So originally they were from stone, and then we discovered metals that we could then use for those tools, meaning bronze and iron. Now we're going to talk briefly about the discovery of the elements. So the first array of elements to be discovered were around 9000 BC were metals. Okay, so metals we've known about for a really long time. One of the first metals was copper, but it had to be extracted from the rock it was chemically joined to, its ore, before it could be used as metal. So copper metal was in a rock as part of an ore, and it had to then be extracted from the rock by heating it, so that you could then take the copper out of the rock, because it was actually part of the rock that they found it in. Now, you do need to be aware of what an ore actually is, because it's quite important later on. So, make sure that you highlight the word ore and then note down what it means. So make sure that you write that ore is a rock and a metal. So it's a rock that basically contains a mineral, and an example of that is then mostly metals. Now the ore looks nothing like metal, so humans had to chemically change the ore to extract the pure copper. And this also then happened with lead and iron. Gold and silver were discovered in 6000 BC, but this time no extraction was needed, as they are very unreactive, which meant that they were present as lumps of metal. So they didn't need extracting, you could just find gold and silver as they are, because they weren't actually part of any rocks. They were not found in ores like lead, iron and copper were. And obviously humans then found these elements very useful for making tools. So metal became the most commonly used material because they had lots of uses for them. Now, one of the first non-metals to be discovered was carbon, which would have likely come from charcoal and was used to extract metals from their ores by heating. So as I've said before, the ores had to be heated and melted down so that you could get the metal out of the rock, and they used carbon, so charcoal, to do that. Now we are going to look at what are properties of an element. So, properties are the way a material behaves, feels, looks, etc. It's the physical way that a material is. It's properties that they have. So you can say that a material is something. So it is hard, or it is tough, or it is flexible. There are many ways to describe and test the properties of a material. The first 20 elements can be divided into metals and non-metals based on their properties. So you can split that periodic table of elements into metals and non-metals based on the way that the materials are. So essentially, properties are what makes the elements, so by them it's meaning the elements, different to each other. So it's the differences between the elements. Make sure that you make a note of that then in your booklet. Okay, we will now look at some of the properties of the first 20 elements in the periodic table, and you need to then be writing them down in this table below. So make sure that you get the element, so the name of the element, its symbol, and then the properties. Okay, when we go through each element, you need to make sure that you are noting down these particular properties of each element. So the colour, how it reacts, and the state of matter at room temperature, so that can be solid, liquid or gas. Okay, so these are the three things that you need to make sure that you are trying to pick out from the videos so that you can write these down in your table. The first element that we will be looking at is sulfur, so make sure that you get the name down and the symbol down. You may need to turn the volume up in order to hear the video properly. Okay, so please do that if you need to.
Sulfur is the 16th element of the periodic table and is a non-metal. In its elemental form, it is a bright yellow crystalline solid at room temperature. In this video, we are going to look at the basic physical and chemical properties of sulfur. We will also discover some real-life applications of sulfur-containing compounds, including how it is found in fuels and what happens when it is combusted and consequently reacts with oxygen. Yellow elemental sulfur burns with a blue flame and melts into a deep red liquid. Its many compounds can be found in everyday life. Does cutting onions reduce you to tears? The sulfur-containing compound responsible for this is a known substance that makes your eyes produce tears. Stinky feet and bad breath, blame those on sulfur-containing compounds too. Overcook those boiled eggs. That blue-grey lining around the yolk is due to the reaction of the iron in the yolk and hydrogen sulfide created in the whites, forming iron sulfide. Ever smelled a natural gas leak? That is actually the smell of a spiking agent, which is a class of sulfur-containing compound called thiols or mercaptans, such as methanethiol. Methane is the gas. The thiol is the sulfur-smelling part. The sulfur smell is strong enough so that you can detect a potentially dangerous leak. In fact, fuel for cars and other vehicles also contain these sulfur compounds. The combustion of these fuels also means the combustion of these sulfur-containing compounds. This results in the production of sulfur dioxide, which reacts with the oxygen in the air to create sulfur trioxide. Bicycle and car tires would not exist without sulfur. Did you know that curly hair has a connection to sulfur? Keratin, the main protein component of hair, also has lots of disulfide bridges. The more bridges present, the curlier your hair. In fact, straightening curly hair involves breaking these bridges, either using heat or chemicals. Do you love the smell of the seaside? That distinct smell is actually from sulfur-containing compounds released by algae and decomposing seaweed, which is very toxic, but present in low enough concentrations so that it is safe for you to enjoy your time at the beach. And finally, and maybe most importantly, sulfur is an essential element to life. It is present in one of the 22 amino acids that make up proteins. So when living things die and get buried underground to form fossil fuels, sulfur remains there, only to be released as a OSO when the fuels are burnt, again leading us back to acid rain. So there you have it, sulfur. Not as dull as you might have imagined. Just remember volcanoes, onions, smelly feet and eggs, gas, fuel, acid rain, curly hair, the seaside, and amino acids.
Now, if you had any issues listening to that video, then you can search up the video yourself. It is done by Fuse School on YouTube, and you just need to then add sulfur when you search, and it should then come up with the video. So you can just watch it on your own, and it's a longer video, so it includes a lot more information, but the parts that I included in this video are the properties that you definitely then need to write in your table. So this is then what your table should now look like. So the element is sulfur. Its symbol is a capital S. Okay, so I have made the writing a bit bigger so that hopefully you can see it a bit better. So the properties that you need to know are that it is a bright yellow solid. It is smelly, so it gives off a particular smell, so much like the eggs and the smelly feet. Okay, that is because of the smell of sulfur. And then the last thing is that it is reactive, and creates many compounds. So for example, iron sulfide. So that is the main things that you need to note within your table, and I'm just going to make that a bit smaller so that the table doesn't take up too much space. Our next video is then of nitrogen, so make sure that again you are filling in your table with the properties. You are looking for the colour, how it reacts, and the state of matter at room temperature.
Nitrogen makes up approximately 78% of the air around us. In this lesson, we will learn about nitrogen, its properties, and its real-life applications. Nitrogen is a colorless, odorless gas at standard ambient temperature and pressure. Nitrogen is extracted from air using liquefaction and fractional distillation. These processes are explained in another lesson. Atmospheric nitrogen is naturally fixed or reacted to form a compound into soils by lightning or certain types of bacteria. Nitrogen is an essential element in the structure of proteins and DNA, but plants cannot obtain it from the air as the nitrogen-nitrogen triple bond is very strong, so it has to be fixed into soils. This is a part of a much larger and important nitrogen cycle, as explained in another lesson. We will first discuss the uses of nitrogen as a gas. Nitrogen gas is used in the Haber process for the industrial manufacture of ammonia. Ammonia is an important starting material in the production of nitric acid, fertilizers, pharmaceutical products, and explosives. For certain chemical and industrial processes, an unreactive atmosphere may be required. This means that the reaction conditions must be made to be oxygen-free. This is because unwanted oxidation reactions may occur, or oxygen may bind to certain substrates and prevent a reaction from happening. These reactions are conducted under a nitrogen or argon atmosphere. Nitrogen is cheaper than argon and more readily available, and would therefore be the choice atmosphere for industrial chemists in such scenarios. The next time you purchase a bag of chips or crisps, notice how the bag is rather puffy. The gas inside the bag is actually nitrogen. As much oxygen as possible is removed, so to prevent bacteria from growing, thereby increasing its shelf life. In fact, nitrogen is very important in the packaging of many food products, from fruits and vegetables to processed foods such as your bag of chips or crisps. Without it, spoilage will occur much quicker, leading to increased waste production. A method to separate compounds on their volatility is called gas chromatography. This is done by flushing an inert or unreactive gas through a provided sample injected in a gas chromatograph. This gas can be helium or nitrogen. Nitrogen is the gas of choice for this technique because the supply of helium on Earth is dangerously low, and as a consequence, its market value has significantly increased. Liquid nitrogen also has many real-life applications. Nitrogen boils at minus 196 degrees Celsius, so you can imagine how absolutely cold nitrogen is. Now you may wonder, what is the use of something that is so cold? Some industrial reactions are highly exothermic, and liquid nitrogen is used to cool down such reactions. Liquid nitrogen is also used to preserve many biological specimens, such as blood and tissue samples. Therefore, it plays an important role in scientific research.
Okay, so for your next part of your table, you should now have nitrogen, the symbol being a capital N. Nitrogen is an odorless colourless gas. It forms compounds through nitrogen fixing. And again, I'll make that smaller just so that it fits in my table a little better. Next two elements, hydrogen and oxygen, are already actually in your table towards the bottom. So you don't need to write those in as extra ones above. Okay, they are already there for you to add to.
In this video, you're going to examine the properties and uses of hydrogen. Hydrogen is a colourless, odourless gas at room temperature and is the first element in the periodic table. As an element, it is a diatomic gas with a molecular weight of 2, making it the least dense of all gases. This low density made it a natural choice for one of its first practical uses, filling airships, but this future ended when Hindenburg airship caught fire on the 6th of May 1937. Hydrogen is easily the most abundant element in the universe. It is found in the Sun and most other stars, and the giant planets like Jupiter are composed mostly of hydrogen. On Earth it is found in water, fossil fuels and living things, but very little as the element on its own. In the chemical industry it is used to make ammonia for agricultural fertilizer, the Haber process, and to make cyclohexane from ethanol, which are needed to make plastics and pharmaceuticals. Thus, metals above hydrogen in the reactivity series normally react with acids to form hydrogen, like zinc with hydrochloric acid. However, if the metals form insoluble salt, little reaction will occur, for example lead in sulfuric or hydrochloric acids. Aluminium metal, although well above hydrogen, is covered with a tight layer of oxide which protects it from acid corrosion. Unreactive metals below hydrogen do not displace hydrogen in acids. The most reactive metals will react with water itself, sodium for example. You can test hydrogen by exposing it to a flame. It ignites with a squeaking pop, and you can see condensation in the tube as water is formed. Although hydrogen is an essential element for life, it doesn't play a particularly active role. It remains bonded to carbon and oxygen atoms, whilst the chemistry of life takes place at the more active sites involving, for example, oxygen, nitrogen, and phosphorus. When fossil fuels form, these more reactive elements are removed during the decay process, leaving the hydrocarbon skeleton behind as crude oil and natural gas. If we compare coal, oil and natural gas and hydrogen as fuels, you can see that when they combine with oxygen, coal and crude oil produce the most carbon dioxide. So using natural gas in place of oil and coal does help reduce carbon dioxide emissions. Hydrogen, which only forms water when it burns, could be the clean fuel for the future. But the hydrogen must be generated from water using replenishable energy.
Okay, so for hydrogen, you should have the symbol as capital H, and it is a colourless, odourless gas. And it can react explosively with oxygen. I'm going to put that as a big. It can also form hydrocarbons, carbon. Something extra that you can also note down is that hydrogen is the least dense element. It is also the most abundant element, so it's the most common found element Next we will be looking at oxygen, so again make sure that you are filling in your table with the symbol and then the properties, looking at the colour, how it reacts and the state that it is at room temperature.
In this video we're going to investigate the properties of oxygen. Oxygen has atomic number 8 and is found in group 16 of the periodic table. It has the chemical symbol O. Oxygen is of course a gas. It has no smell, colour or taste, but without it we as humans would not be able to inhabit planet Earth. When cooled to very low temperatures it will form a liquid and a solid, which are both pale blue. Oxygen makes up 21% of the Earth's atmosphere. It has taken many millions of years to make up this composition. Today's atmosphere seems to now have the perfect balance. Oxygen is used by the human body in a process called respiration. Take a deep breath in. Hold it for a few seconds. The air that entered your body has now been held in the lungs. Some of the oxygen you breathed in has been taken into the bloodstream and transported to parts of the body where it's needed. Respiration is taking place in the cells of your body. Oxygen combines with glucose, building up carbon dioxide and water, and releasing energy. This enables cells to function and our bodies to survive. As you breathe out, air now contains roughly 4% less oxygen than when you breathed in. This has been replaced by another gas called carbon dioxide. The oxygen in the atmosphere also affects our lives in other ways. It reacts chemically with a number of other materials. Oxygen will combine with reactive metals to form metal oxide. This is called corrosion. Most metal oxides are useful as they produce a hard protective layer. Aluminium oxide, for example, forms a protective layer on the surface of aluminium. This grey coating protects the body of the metal underneath from further corrosion. Modern aeroplanes have used this characteristic of aluminium as a choice of construction material. Iron 3 oxide is formed when iron reacts with water and oxygen, and this is not useful. You will know iron oxide more commonly as rust. It makes the metal flaky and weak. The corrosion will eat into the metal, which flakes off as the oxide is built up. There are ways of protecting iron from oxidation. Putting oil on your bike chain, for example. It will protect it from the rust and keep it strong. Oxygen can be produced in the lab by the chemical decomposition of hydrogen peroxide. If the Earth's atmosphere consisted of 30% oxygen rather than 21%, forest fires would start with lightning and would never go out. Life as we know it would be impossible.
Okay, so for oxygen, the symbol is capital O. It is again a colourless, odourless gas, but it was also tasteless. So it's a colourless, odourless, tasteless gas. Reacts with metals to then produce metal oxides. So for the rest of the table, what you need to be doing is looking online, so on Google or wherever else you can have a look, okay, to try and then fill in the rest of this table with these specific elements. So you need helium, chlorine, phosphorus. But then you can also decide which elements to do here. when you are filling in the rest of this table, you need to make yourself aware of whether these elements are metals or non-metals, and two that you particularly do need to actually do are carbon and magnesium. So make sure that you do those two, but in terms of the rest, then you can choose which ones that you do. Try to include a good mix of metals and non-metals. Okay, so now we are going back to the bottom of the table. So now we discuss some of the common elements that are not included in the first 20 elements in the periodic table. So copper, iron, gold, silver, lead, mercury, well, lead is repeated twice there, okay, are all common elements used by humans but are not in the first 20 elements. So most of the elements in the periodic table are metals and have some similar properties. Okay, so properties of metals are the fact that they are shiny, they conduct electricity, conduct heat, and are malleable, so they can be bent without breaking. Okay, so we are going to have a look more about the different properties of metals compared to non-metals. Okay, but that is a brief overview. So just talking about the general properties of metals versus non-metals. So metals are shiny, which means that they shine when light goes onto them. They are strong, meaning that they can withstand impact. Okay, so they are tough, they don't break easily. They conduct heat, meaning that they let heat go through them, so it can pass through these metals. They can also then conduct electricity, meaning that charge can flow through these metals. And they are also then solid at room temperature. Whereas non-metals are dull, meaning that they don't have a shine. If light shines on them, they don't have like a glow to them. They are dull, meaning just that they don't shine. Brittle means that non-metals can break quite easily. They insulate heat, which means that they keep heat in a place that heat already is. So whereas heat normally goes from a place of hot to cold, insulators stop that from happening. So they block the heat energy, the thermal energy, from moving from one place to another. So you can see in the picture that someone is putting insulating into their house to make sure that the heat stays in the house. Non-metals then also insulate electricity, which means that they don't let charge flow through them. It means that it keeps the charge in a particular place, and that is why plastic is used on the coating of wires, so that the charge going through the wires does not then spread to anywhere else. It is just flowing in the wire. Make sure that you copy these properties down into your booklet and make sure that you have a good understanding of what they mean. Well, then you need to be doing the knowledge check, so make sure that you pause the video to give yourself enough time to answer all the questions. Okay, first of all then, so the Earth is 4.5 billion years old. The first metal to be discovered and used is copper. The three ages are the Stone Age, the Bronze Age, and the Iron Age. So, The rock that a metal is chemically combined to is called an ore. The two main categories of elements are metals and non-metals. The basic properties of hydrogen, so it is a colourless, odourless gas, and it reacts with oxygen and carbon. Okay, some of the basic properties of carbon are that it is a black/grey solid at room temperature. It reacts to form carbonates, for example with metals, and it is a non-metal. Okay, so magnesium is like a silver grey solid at room temperature. It is a metal and it reacts with oxygen and water. The early humans managed to extract metal from ores by heating the ores to chemically separate the metal from the rock. Early humans used metal to make tools, and some metals were easier to find than others because some were not combined with rock in ores, so they were just separate things that you could just find and you didn't have to actually extract them. Okay, there is an extra extension activity if you do want to have a go at that, so make sure that you pause the video before the answer appears. Okay, the reason why we have discovered more elements today compared to our ancestors is because we have new technology and we have more information. I mean things such as reactions that can then form new elements. So things such as processes such as electrolysis is a new thing that we have. It's quite recent, and it has enabled scientists to discover more elements. When I talk about recent, it is in comparison with those ancestors 50,000 years ago. It's not necessarily something that's very new now, because it's probably about the 1800s that electrolysis came in, but in terms of compared to those ancestors long time ago, it is new, so that's why I bring that up. Okay, make sure that you have a look through your keyword definitions before the end of the lesson. Okay, and that is now at the end of the lesson. Thank you.